absorption ratio, then we have to use one particular method, or you can say one particular ratio for obtaining this DAR value. And there is another method to know about the insulation condition for that particular electrical equipment. Yes. So the another parameter which we are interested to find out is called as a polarization index. No doubt, this experiment which we have discussed in the last time is a performance-based experiment. Whenever the condition is going to normal, then we have to perform this experiment in our laboratory. If the condition is not going to get normal, then I will shoot one video in which I will calculate the dielectric absorption ratio for particular insulator and the polarization index for particular material, and I will share that video with you, so that in the lab manual you can write that particular observation, and our write-up will get completed. Yes. So today we are interested for the sixth experiment, that is called as the study of thermograph images and analysis based on these images. Let me show you the syllabus of this EIMT subject, and in the unit number 3 we have discussed the concept of thermography. Yes, and based on this concept we are interested to know about what is the thermography analysis and why we are interested to study this thermography analysis. So what is the introduction of this course, or you can say of this particular experiment is, we are interested for the condition monitoring, and we know that there are 4 standards are available, or we can say 4 standard procedures are available. For that particular 4 standard procedure, one method is thermography analysis. The other 3 methods are, one can say the first method is the vibrational analysis, the second method is the ultrasound analysis, the third method is the oil analysis, and the fourth method which we are interested to study today, that is called as the thermography analysis. Yes. So that experiment we are interested for this concern unit. Yes. And I told you I am believing in the concept of whenever we are going to discuss that concept in class, then I will try to take that concept. If the practical is available, then I will try to take that practical after the concept is covered in the particular theory class. Yes. So this thermography we have discussed, and we have started with this unit number 4. Yes. So in the afternoon we will start with the on-load temperature changer condition monitoring, and we will see the dissolved gas analysis is available for this condition monitoring. Yes. So no doubt unit number 1, 2, 3 are there for your in-semester exam. We don't know when your in-semester exam will going to take place. Yes. But the university has mentioned the 5th December is the curriculum end for your 3rd year first semester. Yes. So no doubt before 5th of December we have to wind up all the things, all the practicals we have to wind up. Yes. And the Diwali is there also. Yes. So there might be the chances after the Diwali or before the Diwali, 1 week or after 1 week, you will having the in-semester exam, might be. Yes. We don't know about it. Yes. So start a preparation from the unit number 1, 2, 3. Yes. So if you are getting the time, then you can study one unit in 2 or 3 days, so that it will not burden for you at the last moment. Yes. So this is our today's list of experiment which we are interested. So this compulsory experiment which we have finished earlier, and the 4th experiment we have finished is nothing but the study of various types of earthing. And after that, the 5th experiment is dielectric absorption ratio. And today we are interested for the 6th experiment, that is called the study of thermograph images, and we have to analyze these images based on, you can say, the fault condition available. Yes. So we will go to the today's point, that is called the study of thermograph images, and we have to do the analysis based on these images. And I have already shared you the notes as well as the video lectures as well as the recording session of each unit for the theory as well as the practical on your Google Classroom. So if you are getting time from your busy schedule, then I urge you to go on the Google Classroom and try to check the videos, try to check the notes. Yes, and soon I'm going to post the assignments based on unit number 1, 2, and 3. Yes, so that you have to complete on the Google Classroom itself. Yes, and I will try to minimize the question numbers. So I will restrict the numbers between 2 and 3 only. Question 2 or question 3 are available for per unit, and you have to solve and you have to upload your assignment on particular Google Classroom. Okay, so that might be how to solve or how to upload the assignment. Yes, and you have to remember that for this particular subject you are having the term work. Yes, there is no performance based experiment is available, or there is no oral, or there is no practical is available for this subject. Only you have to submit the assignments and you have to secure the good marks in the unit test, so that your you can say the term work is going to increase. Yes, no doubt the attendance condition is also there for getting a good marks in the term work. Yes, okay. So this is about all the related to the this subject, and today we are interested for the study of thermography images, and we have to do the analysis. As we know that this is the study experiment, so there is no need of apparatus. Yes, but we are interested for the pre-lab question. So the first pre-lab question is we have to define what is condition monitoring, and we have to enlist the different techniques to be used for condition monitoring. So just now I have discussed the 4 different techniques, or you can say standard procedures is available for the condition monitoring. Yes, and how we are going to define the condition monitoring? In a simple word, one can say the regular checkup of the electrical equipment is called as condition monitoring. Yes, so if you are interested to do a regular checkup of our electrical fan, then that can be also called as condition monitoring. Yes, but no doubt we have to use a standard procedures. So either we have to use the vibration analysis, either we have to use the oil analysis, either we have to use the ultrasound analysis, or either we have to use the thermography analysis. Yes, based on this standard procedure, it is also called as condition monitoring. Yes, and the second question is for you. What are the causes of heating in electrical equipment? So you can write in the chat box also, or you can unmute your mic, or you can speak yourself, so that we will discuss this concept more efficiently. We know that we cannot avoid the heat which is going to develop inside the electrical machine. Yes, but we can minimize the heat actually. Yes, so short circuit can be a reason of development of heat. Yes, overload is there. Yes, because of overload there can be a heating is going to develop. Yes, surrounding temperature can be a condition. Yes, obviously. So inside the Rajasthan, or you can say inside the desert areas, the surrounding temperature causes the excess heating inside the electrical equipment. Yes, so we have to think of that particular surrounding condition, and we have to install appropriate insulating material or appropriate conducting material inside the electrical equipment. Yes, any other reason or any other cause which is not covered yet, and that is important. So maximum current capacity can be there. Yes, obviously. We know that whenever we are using a conductor, poor connection, or you can say loose connection, can be a cause of the overheating, or you can say heat develop. Yes, we know that each conductor carries a particular amount of current. Let's say if you are carrying the heater in your hand. Yes, let's say we are interested to boil 1 bucket of water for our daily use. Yes, so what we are going to do, we are going to pour the heater inside the bucket. Yes, and heater is working, or the working principle of the heater is the heating effect. Yes, because of the heating is going to develop inside particular the coil, and because of the heat developed inside particular that coil, the surrounding water is get heated. Yes, but whenever the amount of current increases or the heater draws excess current from the power supply, then that can be a dangerous condition. Yes, we know that generally the heaters are of the range of, they have given the wattage rating for a particular heater. Yes, we know that we are interested for the volts, that is called as the 230 volts in our house. We are interested, we can easily calculate the amount of current I. Yes, so if we are interested to find out the current drawn by particular component, then we have to use the ratio of power divided by voltage. So let's say if we are using 1500 watt heater, yes, at the 230 volt, then we have to divide these two quantities and we will get the current drawn by that particular heater. Yes, same way you can calculate the every current which is drawn by particular component or by particular electrical equipment, and if the current increases beyond its limit, so at that time the heat is going to obviously there, and because of that heat there might be the chances of insulation failure. And we have discussed inside the transformer, generally there are, you can say 50 to 60% are chances based on the insulation failure. So if we can minimize this insulation failure, then we can protect our equipment. Yes, so these are some few reasons. No doubt there are a number of reasons of heat developed inside the electrical equipment. Yes, and being an electrical engineer, our aim is to dissipate that heat in a proper way. Yes, so that thermograph images is related to the heat developed. Yes, and we have discussed one interesting motto related to this thermograph images. So I hope you remember that motto. So what is that motto of thermograph images? See the image, see the temperature, and see the temperature and see the problem. Yes, so you have to see the image. After seeing the image, there is obviously the heat is going to develop, that hotspot is going to identified, and you have to check that hotspot with your real condition. Yes, so obviously you have to dismantle that electrical equipment, you have to power off the connection. Yes, and you have to find out at what point exactly the heat is going to develop. Yes, so that is a interesting motto which the engineers have developed for this thermography analysis. Yes, so we are interested for the working of this thermography images, how these thermography images are produced with the help of thermography cameras, and we are interested to do the analysis. Yes, so let's say the infrared thermography is a technique of obtaining an instantaneous quantified neat picture of object using an infrared camera. Hence, the thermography is one of the latest technology to get the thermal images of component. This is done by infrared camera, which is used to monitor the temperature. So in your interview, it might be asked for you, which cameras we are using for this thermography? So the answer is infrared cameras. Yes, and because of this infrared camera, we can monitor the temperature condition. Yes, also the thermography is a preventive maintenance. So this is the part of condition monitoring, and inside the condition monitoring, we are using the thermography. So it is also called the preventive maintenance, because see, before the fault, we are going to see the image. Yes, and after the image, we can predict in what condition the particular fault is going to arise. So it can be used to detect the problem in variety of system equipments like electrical switchgears, substations, circuit breakers, industrial motors, etc. So we know that inside the industry, we are using the industrial motors, and if we are capturing these thermography images, then we can find out the problem. The thermography is one of the measurement technology which uses the instrument design to monitor the emission of the infrared radiation. So we have discussed that one interesting equation related to these thermography images. In other words, it uses the temperature to determine their operating condition. The surface whose temperature is to be measured is scanned by camera. So I told you that there is a lens is available for that particular camera, and it is going to capture that particular electrical equipment. Obviously, there is a display is available for that particular thermography camera or infrared camera, and on that display we will get the image, or we can take the printout also. A thermal image is obtained on the display screen by the system. The intensity of the electron beam is determined by the signal from director, and position in vertical and horizontal direction is done by the signals. Obviously, the signals are going to send from that particular infrared camera to that equipment, and from that equipment it will get back to the infrared camera. Yes. Thus, the shade of gray color on the surface indicates the target temperature. With commercial camera, it is possible to detect the temperature difference as small as 0 degrees Celsius from of light that we can't see. So that the advantage they have mentioned over here about the thermography analysis. Yes. So here you can see we are interested for the analysis. So I have used the pictures which I have taken from the internet. Yes. So this is the real picture, and if we are capturing this image with the help of infrared camera, then we will observe this amount of hotspot in this particular contact. Yes. So we can know that by this reading of this particular range, there can be a problem inside this contact. Yes. So what we are going to do? We are going to isolate this part particularly, and we will check the connection. So if there is a loose connection are available, then because of the loose connection, there might be the possibility of heating is going to develop. Yes, you can see the next two connections are okay. They are in the range of purple. So this is the range. Yes, so purple is okay. But if we are going to observe the orange or somewhat of orange, white orange, so it is difficult or it is dangerous. Yes, so we can say the fault can be a contact failure. So these are the contacts and they are going to failure in the state. Here is the image. Next image, we can see the screw is available for this connector. Yes, and because of the faulty screw terminal, there is a possibility of heat is going to develop inside this. The other screws or the other terminals are carrying the amount of normal current. Yes. So this can be a second image which gives you the idea how this image or how this thermography analysis is advantageous. Yes. And the third is whenever we are interested for some wrap for our conductor, then if that wrapping is not proper or faulty wrapping is available, then it will develop the temperature or it develop the heat. Yes, and that heat can be detected by this thermography camera. You can see the range 140 degrees Celsius range is going to develop. Yes, and minimum is 20 degrees Celsius. So the axis they have used based on the temperature. So 40, 60, 80, 100, 120 and 140. So you can see about nearly 130 to 140 temperature degree Celsius is going to observe, and this is the condition. If this persists for a long time, then obviously it can into the failure state, and whole assembly is responsible in the failure state. Hence, we have to find out the hotspots first, and after the hotspots, we have to identify the problem in particular component. Yes. Now, what is the principle behind this thermography? So we have discussed the introduction. We have discussed the analysis. Yes. So we are not having the thermography camera in our laboratory. Yes. But no doubt, based on the thermography cameras or based on thermography images, one can predict in which part the fault is going to observe. Yes. We know that the thermal energy is generated from an electrical component which is directly proportional to the square of current passing through it multiplied by component resistance. So this is the formula they have given for the thermal energy. In the electrical engineering or inside the electrical machine, you have discussed this formula in terms of watt loss. Yes, so energy loss. So W stands for energy loss, and that loss is not able to cover again. So that's why we are going to say that is the energy loss. So this energy loss is equal to product of square of current I square and the resistance by that particular component. As the condition of the component resistance deteriorates, its resistance can increase. So if the condition of component resistance deteriorates, its resistance increases. Obviously, if the resistance increases, we know that the losses are going to increase. So it generates the more heat. Then, as the component temperature rises, the temperature resistance rises further. Thus, self-propagating process continue. So तुम्हाला कळत असेल आता की जर एखादं कंपोनंट तुम्हाला कळत असेल की एखादं कंपोनंट जर डिटोरेट्स होत असेल, त्याची ती प्रॉपर्टी लूज करत असेल, तर त्याचा रेजिस्टन्स हा इन्क्रीज होईल आणि त्यामुळे तुमचा करस्पॉन्डिंग एनर्जी लॉस ही सुद्धा वाढेल. सेम वे जर कंपोनंट अजूनच खराब होत गेला तर अजूनच त्याचा रेजिस्टन्स वाढेल आणि इन दॅट प्रोपोर्शन आवर एनर्जी लॉसेस इज गोइंग टू इन्क्रीज. येस, अंटिल कुठपर्यंत जाऊ शकतो तो? अंटिल द मेल्टिंग पॉइंट ऑफ वेटेस्ट कंपोनंट इज रिच्ड मे कॉज द ओव्हरहीटिंग and this is responsible for the overheating in the electrical equipment. By using the thermography for inspection of the electrical system and components under loaded condition, the faulty component can be identified and thus heavy loss of health and wealth is also avoided. We know that our wealth is important, yes, because we are consuming our rupees for purchasing that particular electrical equipment. And if that electrical equipment is in the condition of failure, then we are losing our money. Yes, and inside the industry, this is a crucial part. So the industry has the responsibility is assigned to the maintenance department, and maintenance department must have these infrared cameras, and they are going to do the maintenance, you can say regularly. Yes, I'm not going to say periodically, I'm going to say regularly because it is another condition of condition monitoring. So thermography plays an important role as far as safety is concerned for both human and property. So property is related to the, you can say, the asset, and the human is obviously the operator. When the heat is generated, temperature of the parts rises, and this leads to weakening of components that we know. Because of the continuous generation of the heat, the parts are going to loosen, or you can say weaken, and because of this our equipment is under the condition of failure. Yes, so this is all about the experiment number 5. Yes, and let me show you my screen so that you will get the idea about how the thermography camera look like. Yes, so just a minute, let me share my screen about the thermography infrared cameras. Yes. Okay, so you can see the Fluke is a company which is available. I hope the screen is visible to you, and you are going to see the thermal imaging cameras, the quality images for inspection. Yes, and you can see the image of this thermography camera. So FLIR TG165 spot thermal camera with image storage is available on Amazon of the 48,100. So this is the minimum cost from which the कॅमेरा स्टार्ट्स. सो मी तुम्हाला सांगितलं होतं की कॅमेराची कॉस्ट ही जास्त आहे. सो दॅट इज ओनली वन डिसएडव्हान्टेज, बट अपार्ट फ्रॉम दिस ऑल आर द ॲडव्हान्टेजेस. येस, सो इट इज कॉन्टॅक्टलेस, वी कॅन स्टोर द इमेज in any form, and rapid scanning is available. Yes, so let me share the screen of that Amazon so that you will get the specification of that particular image or the camera. Yes, so I hope the screen is visible to you. So this is the brand FLIR. Yes, and you can see the image over here. So this is the display is available, and there are buttons are also available, and this is the lens which is available, which captures the thermography, you can say the equipments. Yes, here there are different notification or name they have given. So they are using the rechargeable lithium ion battery. Yes, obviously we need the battery, or we need the power supply to work these particular thermal cameras. Yes, so this is the trigger pull image capture. So the button is available. This is the button. The temperature range is from -13 degree Farad to 716 degree Farad, and it saves the image with micro SD card. And you can see 2.0 in color LCD is available. So this is the display information they have given. And intuitive button navigation is available. So these arrow keys are also available. We will discuss this next picture. So this is the whole assembly is available. So you can see the ribbon is also available. And this is the, you can say, the storage card. These are the plugs which you can say we can charge this lithium ion battery. So because we can see this is a rechargeable battery. Yes. So the cord are also available with this. And here you can see how that person is going to capture the image of that particular electrical equipment. Yes. So here that person is going to capture the image related to the heat developed inside his, I guess that can be the machine, electrical machine. And this is the next picture they are going to show. And the contacts are available. You can see the RYB 3-phase contact are available, and the person captures the image based on this screen. And this is the last image. Just a minute. Yes. So this is the very interesting or the new advanced technology which is available for our electrical engineers. Without touching that particular electrical component, we can identify the heat developed for that particular electrical equipment. Yes, and you can see the weight also. So only it carries 400 gram weight is available. The dimension they have given. You can see the about this image, about this item. Yes, and height is also available. The length is also available. Yes, and part number they have given. And I guess there can be a warranty also for this particular thermal cameras. Yes, so here you can see the camera, advanced thermal camera, and you can see the cost also. So it carries a 9,49,000 cost. So obviously there are advantageous cameras are available, or you can say recent cameras are available, which captures a very long distance also. No doubt, this image which he is going to capture is the length is I guess only 1 feet. Yes, but because of these high range cameras, we can capture the range up to, one can say 500 meter or 600 meter, because we know that inside the substation the transmission conductor is overhead and the distance might be 10 meter, or you can say the 20 meter or 20 foot in sometimes. So we have to capture that particular image with the help of long distance. So obviously we need a higher you can say the advanced cameras. Yes, so this is all about this thermal camera, and I guess this can be a mobile smartphone. Android is available which captures the thermal images. So you can read the reviews also. So if you are interested for this particular camera, so you can see the range 79,000 and here is the range 91,000. Yes, 1,21,000. So obviously the cost is very high, there is no doubt, but the advantages are more. Yes. And the batteries we are using here is AAA batteries. So the batteries which we are using inside our rechargeable battery, so that is nothing but the AAA battery. Yes, they have given the dimension, item number, manufacturer, item weight. Yes, and believe me, there is one company is available that is called the Fluke meter. Yes, so I guess you are having that Fluke company. You have heard this word before. And inside our laboratory, if you have studied the network analysis practicals, at that time the oscillograms, the oscilloscopes आहेत ना आपल्याकडे, ते या Fluke कंपनीचे बनलेले आहेत. Yes, and multimeters we are using with the help of this Fluke company. So it is a very good company in the electrical engineering which manufactures the meters, or you can say the thermal cameras, or you can say the multimeters. Yes. So this is all about this experiment, and there is a last point is remain, that is about the post-lab question. So let me share my screen, and we will conclude with this today's session. Yes. So we have to write our conclusion. We have to do the analysis which we have seen in the images. So that we have to write here, and the post-lab question is enlist the electrical application of thermography. So obviously for capturing the heat, we are using this thermography image. What are the advantages and disadvantages? So that we have discussed earlier. or inside the theory class also we have discussed, and list out the observations or problems after studying the thermography images. So we have to make the list. So we have to make the faulty wrap connection is available, faulty screw terminals are available, and contact failure is available. So these three images we have seen this analysis, and we have found the problem associated with this particular electrical component. Yes. So I hope you understood the concept of thermography, and Kapil Thorat has mentioned the FLIR long form as forward looking infrared. Okay, so that is not, I guess, to the company FLIR, and it is related to the looking method. For if we are looking forward, then it captures the infrared, or you can say thermal cameras. Yes, I hope you understood this concept, and in the next class we will discuss the seventh experiment related to this EIMT subject. Yes, so write in the chat box if you understood something related to this thermal cameras or thermal images. Yes, so that can be a point in your project also. If you are going to appear for the 4th year, and if you are looking for a project title, then you can work on these thermal cameras or thermal images, and you can make the project also. Yes. So thank you for attending the class, and we will see you in the afternoon for our theory class. Okay. Until then, I guess all the students have renamed their name, and there is only okay. So all the students have renamed their name, and you can leave the class. Thank you. I will stop the recording over here.